Welcome to the Sheyas Pure Math.
Hi friends, today we are going to discuss increasing and decreasing functions. Differentiation, increasing and decreasing functions. The function f of x is increasing on the interval a to b if f dash of x greater than or equal to 0 for all values of x such that a less than x less than b. The function f of x is decreasing on the interval a to b if f dash of x less than or equal to 0 for all values of x such that a less than x less than b. So in a simple way, how can we say f dash of x greater than or equal to 0, the function f of x is increasing, and f dash of x less than or equal to 0, the function f of x is decreasing. Let us see this increasing and decreasing functions in the graph. In this graph, see the function is increasing. See, you can take any negative value, the function is increasing. At 0, again the function is increasing. At any positive value, the function is increasing. So in general, we can conclude that for all x belongs to R. So this symbol means belongs to. And R is a set of real numbers. A set of real numbers. Real numbers in the sense all real numbers. So how can you conclude? For all x belongs to R, the function f of x is increasing. So for all real values of x, the function f of x is increasing. See, in this graph, this point is -1, -1, and here this point is 1, -1. So here the graph is increasing from -1 to 0, -1 to 0, the graph is increasing. And from 0 to 1, the graph is decreasing. So -1 to 0, the graph is increasing, and 0 to 1, the graph is decreasing. Let us solve some problems under increasing functions. Show that the function f of x is equal to x cubed plus 24x plus 3 is increasing for all real values of x. So here, the given function is f of x is equal to x cubed plus 24x plus 3. Now, we have to prove that the function f of x is increasing. So, what is the first step? You have to find f dash of x. So, what is f dash of x? X cube differentiation is 3x square and 24x differentiation is 24. Here, in this is a square. So, x square is greater than or equal to 0 for all real values of x. For all x belongs to R. So in symbol notation we can write for all x belongs to R. So all real values of x can be written as x belongs to R. Which means that this x can take positive values, then also it will be greater than or equal to 0. It can take negative values, then also it will be greater than or equal to 0. And also 0, x can take the value of 0. The inequality is satisfied. If x square greater than or equal to 0, then we can conclude that 3x square plus 24, 3x square plus 24 greater than or equal to 0. So what is this? F dash of x. So f dash of x greater than or equal to 0. So this is greater than or equal to 0 for all real values of x. So f dash of x greater than or equal to 0. Therefore, we can conclude f of x is an increasing function because the condition is f dash of x greater than or equal to 0, then we can conclude that the function is an increasing function. So next problem, find the values of x for which f of x is an increasing function given that f of x equals 4x minus 3x square and all these problems. So what is the given thing? So here these functions are increasing. Given that these functions are increasing, so what we have to find? You have to find the values of x for which these functions are increasing. So once again I repeat, these are increasing functions, and what we have to find? We have to find for what values of x these functions are increasing. So in these problems I will solve A, D, G, H here, and you can try B, C, E, F. So B and C is similar to A and E and F are similar to D. However, I will give you the solution of all these 4 problems at the end of this video. So A problem, 4x minus 3x square. So the function is 4x minus 3x square. Now what is the first step? We have to differentiate that. So f dash of x is equal to 4x differentiation is 4 and 3x square differentiation is minus 6x. So we know that this function is increasing. So given that the function is increasing, so we can write, since f of x is an increasing function, what can we write? F dash of x is greater than or equal to 0. This is the condition. So f dash of x greater than or equal to 0, 4 minus 6x greater than or equal to 0. So minus 6x greater than or equal to minus 4. So here I am multiplying this inequality with a negative sign. Multiplying by negative sign. So if I multiply this inequality with a negative sign, this becomes positive and this also will become positive. If we multiply any inequality with a negative sign, the inequality changes. So 6x less than or equal to 4. So x less than or equal to 4 by 6. X less than or equal to 2 by 3. So for x less than or equal to 2 by 3, the function f of x is increasing. So you can take any values less than or equal to 2 by 3 and you can check. Definitely you will get f dash of x greater than or equal to 0. So for all values which is less than x less than or equal to 2 by 3, for all values of x less than or equal to 2 by 3, the function f of x is increasing. So next problem, f of x is equal to x power 4 minus 8x cube. So again the function is increasing and we have to find the values of x for which the function is increasing. So what is the first step? You have to find f dash of x. So x power 4 differentiation is 4x cube minus 8x cube differentiation is 24x square. Since f of x is an increasing function, we know the condition f dash of x greater than or equal to 0. So what is f dash of x? 4x cube minus 24x square is greater than or equal to 0. So what I am doing is, I am taking 4x square outside, that is common from both. So remaining you will have x here and minus 6. So just multiply this and see, check. 4x square into x is 4x cube and 4 into 6 is 24x square. So greater than or equal to 0. So here x minus 6 greater than or equal to 0. So x greater than or equal to 6. So here what I am doing is, if I take any values greater than or equal to 6, suppose if I am taking 7, definitely this will be greater than or equal to 0. In this case, if you take any values for x, positive or negative or any values, definitely it will be a positive value because you have a square here. But in this case, if you take any values greater than 6, then definitely this inequality will be satisfied. The answer what you will get is greater than or equal to 0. But if you take any values less than 6, suppose if you are taking 4 or 5, this inequality won't get satisfied and you will get a negative value here. So I am concluding that for x greater than or equal to 6, the function f of x is increasing. Just let me take some example and confirm that, okay? So these points are not needed, but to make it clear, I am taking x is equal to 7 and a negative value also, okay? So x is equal to 7, I am substituting this x is equal to 7 in this place, in f dash of x. So 4 into 7 square, 7 minus 6. So here definitely you will get a positive value since it is a square, and here again a positive value because 7 minus 6 is 1. So definitely this will be greater than or equal to 0. So it will satisfy this inequality. So x is greater than or equal to 6. So we have took a value which is greater than or equal to 6 and we have confirmed that the function is increasing. Suppose if you are taking any values less than 6, for example 5. So here we have took a value which is greater than or equal to 6, and here we are taking a value which is less than or equal to 6, for example. So x is equal to 5. So substitute here in f dash of x. So 4 into 5 square, 5 minus 6 is greater than or equal to 0. Just see here. So this will be definitely a positive value, but 5 minus 6 is a negative value. And if we multiply anything with a negative value, we will be getting 4 into 5 square, which does not satisfy this inequality. So this condition will become invalid. So we are concluding that for x greater than or equal to 6, the function f of x is increasing. So when you are solving the problem, all these are not needed. You can write these steps alone. The given function is 3 plus 3x minus 3x square plus x cube. So what is the first step? F dash of x. So when you differentiate 3, it is 0, and 3x differentiation is 3 minus 3x square differentiation is minus 6x, and x cube differentiation is 3x square. Since f of x is an increasing function, our condition is f dash of x is greater than or equal to 0. So what is f dash of x? 3 minus 6x plus 3x square greater than or equal to 0. So from this I am taking 3 outside. So 1 minus 2x plus x square greater than or equal to 0. So here, do you remember the formula? A minus 2ab plus b square, that is a square minus 2ab plus b square, can be written as a minus b the whole square. So in the place of 1, you can write it as 1 square. 1 square is nothing but 1. So minus 2ab, and b is x here. So 1 square minus 2ab plus b square can be written as a minus b the whole square. So here a is 1 and b is x. So I am writing it as 1 minus x the whole square greater than or equal to. So you can take any values for x, whether positive or negative or 0. So any real values of x you can take, and definitely you will be getting the value greater than or equal to 0. Since it is a square, for all values it will be definitely greater than or equal to 0. And so you can conclude that for all x belongs to R, that is nothing but for all real values of x. So how can you write that? For all real values of x, the function f of x is increasing. So the next problem is f of x is equal to 2x cube minus 15x square plus 36x. So what is your first step? f dash of x. So 2x cube differentiation is 6x square and 15x square differentiation is minus 30x plus 36x differentiation is 36. Since f of x is an increasing function, we can write f dash of x greater than or equal to 0. So f dash of x is 6x square minus 30x plus 36 is greater than or equal to 0. So from this I am taking out 6. So when I factorize, I will get x minus 2 and x minus 3. So you can take out 6 and then remaining values you can factorize using your calculator, which is greater than or equal to 0. Then you can consider the three regions. That is, you can take x less than or equal to 2, x greater than or equal to 2, then x less than or equal to 3, and x greater than or equal to 3. I'll tell you in the end why we are taking all these four values. So here what I am doing is, I am linking these two regions. I am making these two regions as a single region. See, I am keeping this region as such, x less than or equal to 2 as such, then 2 less than or equal to x less than or equal to 3, 2 less than or equal to x less than or equal to 3, and the other region x greater than or equal to 3. See, for example, x less than or equal to 2 region we are considering. So x less than or equal to 2, we are taking some values which is less than or equal to 2. For example, I am taking x is equal to 1. So let us take x is equal to 1. If x is equal to 1, I am applying one value, I am applying 1 in the place of x. So 6 into 1 minus 2, 1 minus 3 greater than or equal to 0. So what will you get? So when you multiply all these values, you will be getting 12 greater than or equal to 0. So 12 is greater than or equal to 0, and we can conclude that for any values less than or equal to 2, this inequality f dash of x is greater than or equal to 0. Just take the next value, x greater than or equal to 3. I am taking this region. So x greater than or equal to 3. So let us take any value greater than or equal to 3. So I am taking x as 4. Again I am substituting in this. In the place of x I am substituting 4. So when I substitute 4 minus 2, then 4 minus 3 greater than or equal to 0. Again when I multiply all these values, I will be getting 12 greater than or equal to 0. So here also I am getting f dash of x greater than or equal to 0. So I am considering the third region, 2 less than or equal to x less than or equal to 3. So I am taking some values between this 2 and 3. So let us take some values between this 2 and 3. Let it be 2.5. So when I put this 2.5 in the place of x in f dash of x, what will you get? 6 into 2.5 minus 2, 2.5 minus 3 is greater than or equal to 0. But when you multiply, what answer you will be getting? When you multiply this, you will be getting minus 1.5 greater than or equal to 0, which is invalid. So this is invalid because a negative number cannot be greater than or equal to 0. So this condition is invalid. So we can't take this region. 2x less than or equal to 3 is not possible. So for these two values alone, x less than or equal to 2 and x greater than or equal to 3, we are getting f dash of x greater than or equal to 0. So I am concluding, for x less than or equal to 2 and for x greater than or equal to 3, the function f of x is increasing. For x less than or equal to 2 and x greater than or equal to 3, the function f of x is increasing. So whenever you get two values, better consider the four regions and link it together and make it a single region. Then take these three regions and confirm for which region the function is decreasing or increasing. So we conclude here, for x less than or equal to 2 and x greater than or equal to 3, the function is increasing. Here in this problem, I have given the solution. So this problem is similar to the A problem what we have done. So this is the C problem and this is similar to the A problem. So this is the E problem which is similar to the D problem. So this is the F problem which is similar to the D problem. In the next video, let us discuss the problems under decreasing functions. If you have any doubt in this increasing functions, please post it in the comment box. Thank you.
Thanks for watching. Like and comment. Please to subscribe to our channel.